Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you. This is the DADM 1 course under the MOOC-NPTEL series, and we are covering the topics of statistics in all its depth, and this is the 10th lecture. So, as you know, this is a course for 30 hours, 12 weeks spread over 12 weeks. Each week we have 5 lectures, each lecture being for half an hour, and 10th week means we are going to finish the second week. So, I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember that in the 9th lecture, just at the last few slides, we were discussing about continuous distribution, we did discuss about exponential, and then we went to normal distribution. Now, one thing if you remember, when we are discussing the discrete cases, I did mention about the Poisson distribution, and I did mention another important point is that it is basically the number of such readings you are going to take per unit time, and that per unit time I mentioned a time and again conceptually. So, obviously, I mentioned the second point also, which I will come. So, it was basically between any unit time, that unit time can be 1 hour or can be, say for example, 30 minutes, can be 2 seconds, 1 nanoseconds. That is generally what I am trying to hint at, what you mean by the concept of per unit time. But the actual distribution comes out to be true as that delta time tends to 0. So, hence the Poisson distribution comes out. Now, when I was discussing the exponential distribution, I did not mention that point, but I will try to definitely bring it into the discussion now before I again continue. So, say for example, you are standing in front of a queue, or you are basically trying to process materials or machine objects or some jobs which are coming for being processed in a machine, or you are standing in front of a tailor machine or a tailor window in the bank, whatever it is, or say for a counter where food is being served, whatever it is. Now, you have a stop clock in your hand and you measure two things simultaneously. Consider that as possible for you. Number one, you measure the number of people who are entering, coming per unit time. In that unit time you have to decide, as I said, and you are also measuring the time taken to process each and every unit which is entering. So, say for example, it is a bank teller machine, a person is sitting and people are entering the queue per unit time. So, that would be discrete, and as you decrease the unit time, that discrete distribution becomes a PMF, which is actually the Poisson distribution. Now, if you go to the case where you are trying to find out the amount of time taken to process each and every customer, that may be somebody may have brought his or her passbook to be updated, somebody wants to withdraw money, somebody wants to get a demand draft, somebody wants to basically deposit money. So, obviously, everybody would have different times to process their request. So, if I basically consider the time, then it basically becomes an exponential distribution. So, there is a very underlying linkage between Poisson and exponential distribution. I will come to that later on also. Exponential distribution can also be utilized for the cases where you want to basically find out the working life of a machine, working life of, say for example, a bulb, whatever it is. An exponential distribution is memory loss process, in the sense that whatever the probability of failure or probability of working was, the instant basically you want to again start counting, it would have no information set from the past. So, it is basically a memory loss process. Another thing, a very interesting fact is that I should have mentioned during the discussion of Poisson distribution, but Poisson distribution basically came into the light. A very interesting historical fact is that during the Prussian war, so where cavalry was used as the main thrust for the wars, so many soldiers were killed by being trampled by the horses as they fell down. So, it was found out that the number of people who died in such accidents was basically the distribution was distributed as Poisson distribution. So, that is one another historical reason. So, there are other historical backgrounds also, but I thought I should mention to you that this. Now, So, these are some of the I will not say the missing link, some of the information set which I thought should be shared with you, so that it will basically be much more interesting for you to understand the concept. Now, if you remember, I did discuss the normal distribution. Normal distribution has the same mean, so the same mode and the same median. Mode, if you remember, is the value which is occurring in the highest probability wise or frequency wise or relative frequency wise. Number 2 point is mean, is basically the center of gravity or center of mass of that distribution. So, mean, mode are the same for the normal distribution, and median is that value of x which divides the total distribution in two equal halves. When I mean this two equal halves, it basically implies that the probability, that the cumulative probability or addition of all the probability values till that value of mean, median, and after the median are equal, and they are equal to 0.5. So, let us consider first the case of an exponential distribution. So, consider Mr. K. Bharadwaj, an electrician, knows that the time a bulb operates before it gets fused is exponentially distributed with a mean life of 100. What is the probability that any bulb will work continuously for at least 200 hours? Now, if you remember, for the exponential distribution I did discuss, there are two parameters, A and lambda. Now, A value is basically the minimum working life of that particular component for which you are trying to find out the distribution, and the distribution exponential. So, if there is a bulb, consider that, and the bulb may fail instantaneously the moment you put on the switch. So, in that case A would be 0. So, in the example which you are going to consider, the mean value which you know, the formula is A plus lambda, here A would be 0, hence lambda is 100. So, based on one fact we will basically proceed. It may be possible that for some machines where you want to find out the exponential distribution being used for the case of trying to find out the working life of that machines, but there is a warranty life, that means the machine would never fail before, say for example 6 months. So, in that case A would be 6, and you will basically calculate the corresponding probability and all the set of information which is required based on the fact that A is 6 months or half a year. So, in this case theta is 100, obviously A is 0, hence the required probability would be x, probability of x being less than is greater than 200, or it will be 1 minus probability of x being less than equal to 200. So, here less than and greater than would not make much of a difference, I will come to that later on. So, hence we want to find out the probability, we integrate it. So, when you are integrating it, I will just use the dark color. So, this is the axis, the distribution is this, consider again, let me use the black color. So, this is say for example 200, and this is f of x. F of x is basically the exponential distribution. So, you will integrate all the values. So, let me use again the another color, blue. So, I will find out all the PDF summed up. So, the cumulative values, and this whole area, that means starting from 0 to infinity, this whole area is basically 1. So, 1 minus that blue area, hashed area, would give me the corresponding probability. So, that is what is given here. Say for example, if I want to find out, so obviously I will be coming to that. I want to find out the probability that the bulb will survive between a time period of 200 to 300 hours. So, obviously, you need to do the calculations accordingly. I will draw the picture, it will make things much clear to you. So, this is, let me draw it in black. Okay, let me use the red one. So, this is 200, this is 300. So, the bulb is surviving between this time period. I need to find out this. Let me highlight it. So, this would be given by the corresponding area between 200 to 300, 1 by 100. I am taking the same distribution, exponential minus x by 100 dx. You find out and then do your calculations accordingly. An assignment, again an assignment I am telling, it is based on the fact that they are to be solved by you, not to be graded from our side. So, it is Mr. Lindo, the owner of an electronic shop, knows that the average life of a tape recorder he sells is 1.5 years. What is the probability that any such tape recorder would function for at most 3 years? So, again we are considering that it may be possible, the moment you put on the tape it would have failed. So, obviously, A would be 0. So, in that case you will consider lambda or theta whatever it is equal to 1.5. The recorder would have functioned for at most 3 years. That means, I want to find out the total probability, which is 3 years and beyond. So, it will be the distribution, this is the value of 3 years. So, if I draw it, it becomes this. So, I want to find out till infinity. So, we want to find out what is the probability that any such tape recorder would function for at most, okay, at most 3 years would be on the left hand side. My apologies. So, I did not read it properly. So, at most 3 years would basically be on the left hand side. So, maximum 3. So, in that case let me erase it. So, it will be easier not to be confused. Yeah. So, in that case I use the pen. So, this is the probability. Now, we consider the log normal distribution. So, x, where x is the random variable, ln is the log normal distribution, and mu and sigma square are the parameters. So, x value is for the log normal distribution, remember log of values of negative are not possible, hence log of the x value would be from 0 to infinity. Mu x and sigma square x, again the suffix basically denotes they are the parameters, where mu x is a real along the real line and sigma square would obviously be greater than 0. The exponential, the expected value and the variance values are given as shown. So, examples are stock prices, returns, distribution, they can be considered accordingly. So, in the log normal distribution, look at the distribution PDF, it would be almost equal to the normal distribution. So, obviously, the first part I will use the blue, let me use the color black. So, this part is the same, and obviously, you would have 1 by x and e to the power mu. In the case of the normal distribution, you had mu minus sigma square. So, this is log of x minus mu whole square divided by 2 sigma square. So, these values are only different, and based on that you can find out the log normal distribution. This is the log normal distribution, and again along the x axis you have the x values, along the y axis you have the PDF values, and you can calculate the corresponding probabilities whatever they are as required. Now, if you remember, I did discuss about just when I had just started the class, and on the slide the 10th lecture number was there. I did mention the relationship between exponential and Poisson distribution. So, here it is. I will again repeat it. If a process has the intervals between successive events as independent, and I did mention that idea also. So, intervals and the arrivals time and the numbers coming are independent of each other between two intervals, and intervals are of same equal length. So, if a process has the intervals between successive events as independent and identical, so obviously these are IIDs and it is exponentially distributed, then the number of events in a specified time interval will be a Poisson distribution. So, the relationship being numbers arriving is Poisson and the time taken to process them is exponential. The cumulative distribution function of the CDF. So, we denote the distribution function by f of x, capital F of x, and f of x being the case where you have the probability of x less than equal to x, that is given by the summation of all the values for x till that value. So, if you have basically the you want to find out the CDF values for the case when it is the uniform distribution and it is between say for example 1 to say for example 10 and they are only integers. I want to find out the cumulative distribution for the values less than equal to say for example 3, then I will add up the PMF values for value 1 plus 2 plus 3. If I want to find out the value of the CDF values for x values greater than 5 in the same case. So, it will basically be the sum of the PMF values of 6, because 5 is not included and obviously 5.5, 5.75 all these things are not possible because they are discrete distribution. So, in that case I will add up the probabilities of value of 6, 7, 8, 9 and 10. If I want to find out the values of the cumulative distribution for the uniform discrete case, for the case when it is inclusive of 3 and exclusive of 5 less than 5, but greater than equal to 3, then I add up the probabilities PMF values of 3 and 4 only. So, in the case if it is a continuous distribution, so obviously in that case summation will be replaced by integration. So, when as I showed you, when you have the exponential distribution, log normal distribution, in that case I will utilize the concept of integration to find out what is the cumulative distribution values for x between two values. So, if I write technically, obviously I am not going to go in the details, but technically when I write for the continuous case and for the discrete case, the formula like probability of x between A and B both being inclusive. So, if I have say for example this, let me write it here. So, it will be easy for so, if I write probability, I am using PR for probability, please, here it is not written, it is only P. In the discrete case, it will mean that I include the probabilities of PMF of A and B both, that is one. So, in the discrete case, this versus this are different, because in the later case the value of, let me highlight it. So, this value where A is not included would definitely change the overall cumulative values, but for the normal case it would not be case in the same, because consider this very, I am trying to explain it is in a very layman terms for us to understand, because in that case there are between the value 1 and 10 there are infinite values. So, whether you start from A or start from A plus delta, that would not matter, and then you basically some slight shift onto the right of A would not matter. So, the values which I have written here, considering x is between A and B both inclusive and x is between A and B, A not being inclusive, for the case of the discrete case it will be different, for the case of the continuous case it will be same. So, properties of the distribution function, this distribution function is basically means it is the CDF value I am talking about, and I am using capital F of x. So, small f of x is basically the PMF for the PDF. So, f of x is non decreasing in x, that is if x 1 is less than x 2, then f of x 1, capital F of x 1 is less than equal to x 2, because for any PDF values or PMF values, the values cannot be 0. So, they are either increasing or at this fixed value. So, if it is less than, it means increasing, less than equal to, equality sign would be for true for the case where it is true that they are basically equal. Now, remember one thing, if you consider the CDF values, what does CDF value means? I am basically adding up, whether cumulative or integration. Now, if you do the reverse mapping, that means you want to find out the value of small f given capital F. So, obviously, it will be very simply we can understand that as f is equal to the integration between some values, consider x 1 to x 2 f of x dx. So, in that case capital, let me expand capital X f to for your and for our better understanding. So, it will be given as f of x 1 less than equal to capital X less than equal to small x 2. So, this would be true, and obviously, when I want to find out the probability of x 1 less than equal to capital X less than equal to x 2, then in that case I sum them up. So, it will be all values of x which is element starting from x 1 till x 2 both being included. So, if for the less than equal to sign, less than equal to sign. Now, when I go the reverse way, so obviously it would mean df of dx for the case when it is continuous. So, let me use for the continuous case. So, obviously this would be true. Or else in the case when you have the discrete case, this is the continuous case, the discrete case would be f of x 2 at x is equal to minus f of x 1 divided by x 2 minus x 1. So, this will give me the PMF value at that point when it changes from x 1 to x 2. The standard normal distribution would be utilized in all the problems. So, putting z is the standard normal deviate is equal to x minus mu by sigma, and using very simple one dimensional Jacobian transformation. So, it can be done for multivariate case, you will use the multivariate Jacobian transformation. Putting z is equal to x minus mu divided by sigma, which is basically the normal distribution, we will have the standard normal, but in this case the corresponding standard normal distribution would have not mu as the mean, but it will have 1 as 0 as the mean value, and it will not have sigma square as the variance, it will have 1 as the variance of that z, for which obviously the standard deviation value would also be 1. So, if you look at the z distribution, it will look, the diagram is going to come within few minutes, but I will just draw it. So, this would be the standard normal, this would be the mean value which is 1 as I mentioned that. So, this would be the mean value corresponding to the standard normal deviate, and the variance which you will have, oh sorry, this will be the 0, my apologies. So, it will be 0, and the variance values for the standard normal deviate. So, this is sigma z, this is sigma z, this value would be 1, this value would also be 1. So, plus minus 1 you will have. So, here mu z is, the color change would help. So, this is what I am talking about, and when you have this, this is the value which I am talking about. So, remember f of x, which is the CDF values for x, probability x being less than equal to x, you will also have the same values as z less than equal to z, because you are doing a one to one transformation. So, f of z, which is the PDF value for the x as a normal distribution, the corresponding PDF would basically be given by small phi of z. And when we have the cumulative distribution values, So, f of x, that means you add up all the values for x starting from minus infinity to 0. So, obviously, the corresponding values in the case when you have the standard normal deviate would also be from minus infinity to the small z value, where x and z have a 1-to-1 correspondence, that would be given by capital as Z. So, remember one thing, if you look at the Z distribution, the mean value being 0, which means the values equidistant onto the left and the values on equidistant onto the right are equal. That means, it is a symmetrical values are there on the left hand side and the right hand side. So, if you go plus 1 sigma onto the left and plus 1 sigma onto the right, the corresponding z values would be equal in magnitude, but they would be of opposite sign, because if you are considering from my side I am considering. So, 0 is here. If I go left, you will have basically the minus z values if you till in minus infinity. If you go to the right, it will go to plus infinity with all positive values. So, this is the standard normal distribution, this is the 0 value, this is basically I would have the variance here. So, that is basically plus minus 1, and again along the x axis you have the x values, along the y axis you have the corresponding PDF values being drawn in a way where you can find out the corresponding, and then you can plot the corresponding PDF for the standard normal. So, normal results distribution rules, the value of small phi minus z corresponding to the fact that it is equally onto the left, equally onto the right. So, small phi minus z, it will be equal to small phi plus z, because let me draw it. So, this is z. See, if I go minus 2 or minus 3 onto the left, and if I go plus 2 plus 3 to the right, the values of the height, because small phi means basically corresponding to the probabilities. So, they would be same. So, this value is equal to this value is equal to this value, and so on and so forth. The corresponding capital phi minus z. So, that means, I am taking, let me delete it. Let me delete it, I am taking the pen. So, if this is z, minus z is here. So, if I find out this, so this would be all the values till minus infinity to plus infinity. If I get positive one, so obviously these values are all be equal. So, I have to 1 minus this would basically give me the corresponding probabilities, which I am trying to find out for the case of this. So, these values would basically give me the CDF values starting from minus infinity to plus z. So, 1 minus the corresponding value onto the right would give me the CDF values from minus infinity to minus z. Probability of A being less than x being and x being less than minus beta. So, obviously, when you do the transformation in the standard normal case, it will be x becomes z. So, the corresponding values of A would now become A minus mu x divided by standard deviation of x, and B would become B minus mu x by standard deviation of x. And if A tends to minus infinity, then the actual corresponding values of capital phi would basically be 0. So, in that case, probability of x less than beta would basically be all the values added up from minus infinity to beta value. And if beta becomes positive infinity, so obviously you would add up all the values from minus infinity to a, and 1 minus that would give you this value. So, I will again come back to using the problems, you will understand in much details as you do the assignments and understand and read the book. So, with this I will close the 10th lecture, which is the end of the second week, and wish you all the best of luck, and thank you very much.